Good morning, class. So this morning we are going to talk about acids and bases. So here are the learning competencies that we have to accomplish o yung mga kailangan nyo matutunan for this lesson. First, we are going to define bronzer and Lowry acids and bases. Pero medyo i-cover din natin yung dalawa pang types ng acids and bases para mas malawak-lawak naman ng konti ma-discuss natin. We also have discussed the acid-base property of water and calculate the pH from the concentration of hydrogen ion or hydroxide ions in aqueous solutions. Now, for the last two learning competencies, you describe how a buffer solution maintains its pH and calculate the pH of a buffer solution using the Henderson-Hasselbalch equation. Hindi muna natin i-cover yan sa video na to kasi medyo komplikado yung calculations niyan. Yung gagawin pa nga lang natin na solving sa lesson na ito sa calculation of pH from the concentration of hydrogen ion or hydroxide ions in aqueous solutions, medyo mahihirapan na kayo ng konti dyan. Kaya hindi muna natin sasama yung sa buffer solution and the Henderson-Hasselbalch equation. Okay. Now, let us define acids and bases. So, we have three definitions of acids and bases, pero sabi nga natin, pinaka-focus natin itong Bronzer and Lowry acids and base. So, first is the Arrhenius acid. So, an Arrhenius acid or an acid according to Arrhenius is a substance that ionizes in water to produce hydrogen ions, okay, or H+. So, example, we have hydrogen chloride, okay? If you dissolve this in water, it will dissociate to form hydrogen ion and chlorine ion, okay? So, since kapag dinisolve natin si HCl sa water, nag-produce siya ng H positive, according to Arrhenius, HCl is an acid. Okay? So, yung other form yan, kapag in-include na natin si water dun sa equation, so, imbis na H plus yung nasa equation natin, we will have hydronium ion. We call this as hydronium ion. Kasi, ang hydrogen ion, hindi naman talaga siya nag-exist as H positive lang talaga. Normally, itong hydrogen ion na ito, nakikipag-interact din sa water molecules to form the, what we call as hydronium ion. Yung pinakasimpleng form ng water plus H positive. Okay, medyo complicated yung structure talaga niyan, tunay na structure niyan. Pero yung pinakasimple natin, ito ay H3O positive, yung hydronium. Okay? So, it's either H positive o H3O positive yung mapoform ng acid kapag siya ay nag-dissolve sa water. Okay, now how about an Arrhenius base? An Arrhenius base is a substance that ionizes in water to produce hydroxide ions naman, OH negative. For example, we have sodium hydroxide. When you dissolve this in water, it will form sodium ion and hydroxide ions. So, since yung substance natin na sodium hydroxide ay nagdi-dissociate in water to produce hydroxide ion, then sodium hydroxide is an Arrhenius base. Okay? Now, may problema kasi dito sa definition ni Arrhenius. Kasi may mga substances na classified as base, pero wala siyang, kumbaga hindi siya nagdi-dissociate to form hydroxide. Walang hydroxide dito sa ammonia natin. Pero, isa itong base. Okay? Ay, nakapag-produce ng OH, pero wala namang OH dito. So, paano siya na-classify as a base? So, hindi siya sakop ng definition ni Arrhenius. At isa pa, yung water mismo, anong type ng substance siya? Acid ba siya or base? Kasi, ang water, okay, it can self-ionize. Kaya niya mag-dissociate. Kaya niya i-dissociate yung sarili niya to form hydrogen ion and hydroxide ion. So, anong type ng substance si water? Acid ba siya? Or base? So, yun yung medyo limitations ng definition ni Arrhenius. Kaya meron tayong sumunod na definition ng acids and base. At ito na yung tinatawag natin na Bronsted-Lowry acid and base. Dalawang scientists kasi yung yung sabay na nakapag-develop ng idea na yan. Si Bronsted at si Lowry. Hindi ko nabibigay sa inyo yung first names nila dahil hindi naman lalabas din sa exam. Basta Bronsted-Lowry acid and base. Okay? Now, according to Bronsted-Lowry, an acid is a substance that donates proton, while a Bronsted-Lowry base is a substance that accepts proton. Okay? Now, ano ba yung tinutukoy dito na proton? Okay? What this actually refers to is the hydrogen ion. Okay? Or yung hydronium ion. Okay? Now, bakit tinatawag natin na proton yan, itong H positive? Kasi again, di ba, ang hydrogen atom ay may isang proton sa gitna at may isang electron. Okay? Nakaikot-ikot dun sa proton niya. Now, kapag ito kasi, electron natin na ito ay natanggal, kunwari yan, nariyan ay natanggal. Okay? Yan, natanggal, nakuha ng ibang ng ibang atoms. Then we are only left with our proton. Okay? Ito na lang yung matitira sa atin, which is positively charged. Kaya yung H positive, proton lang talaga siya. Kasi natanggalan na siya ng electron. Okay? And again, yung H positive kasi na hindi siya normally nag-exist ng mag-isa. Naghahanap yan ng mga kakabitan. So, kakapit siya kay water to form what we call as hydronium ion. Okay? So, again, Bronsted-Lowry acid nagdo-donate ng proton or hydrogen ion, while a Bronsted-Lowry base accepts a proton. Siya naman yung tagatanggap ng binigay ng acid. Okay. So, example natin ng Bronsted-Lowry acid ay, again, yung HCl. Nagko-complement pa rin ito sa definition ni Arrhenius ng acid. So, halimbawa, ito. So, we have HCl. When it reacts with water, yung H ni HCl ay idodonate niya kay water. Diba? Sabi nga natin, ang Bronsted-Lowry acid ay nagdo-donate ng proton. Si HCl nag-donate ng proton kay water. So, therefore, this is an acid kasi nag-donate siya. Okay? So, ito yung magiging products natin. Hydronium ion, okay? Which is yung hinahanap natin sa isang acid. Dapat mataas yung concentration yan. And a chlorine ion. Okay? Another example is acetic acid. Okay? This is, hindi nakasya sa akin, acetic acid. Ayan, sulat pa natin. Acetic acid. Meron siyang hydrogen atom here na madali niya madidissociate. I-donate niya yun kay water din. Okay, to form ito, another hydronium ion and itong CH3COO negative or acetate ion. So, that's a Bronsted-Lowry acid. Itong HCl and yung acetic acid natin, sila ay nagdo-donate ng proton. Okay, now how about a Bronsted-Lowry base? Sabi nga natin, this is a substance that accepts proton. Example natin itong ammonia. Okay, so si ammonia, okay, wala siyang OH, di ba? Pero pwede siya maging base sa paanong paraan. Itong hydrogen is kasi ito, di ba? H, O, and H. Itong isang hydrogen na ito ay pwedeng mapunta kay ammonia. Okay, kakapit siya dyan kay nitrogen to form ammonium ion. This is ammonium. And, syempre, dahil natanggal na ito, ayan, meron na tayong natitira. Meron pa tayong OH. So, ito na yun. Okay? So, yun. So, si ammonia, siya ay proton acceptor. Tagatanggap siya ng proton na binigay ni water. So, in this case, water is an acid and ammonia is a base. Bakit naging acid si water dito? Kasi siya ay nag-donate ng proton. Okay, at ang nag-accept naman ng proton na yun ay si ammonia. So, siya ang base. Okay? Balikan natin yun sa task kanina. 'Di ba? Si HCl ay acid dahil si water ay tumanggap ng proton. So, therefore, water is a base. Okay? Ganon din dito, dahil tumanggap ang water ng proton mula kay acetic acid, then water also here is a base. Pwede siya mag-act as a base. Pero kapag ang kasama naman ng water ay isang base, mag-act naman siya as an acid. Okay? So, yun. So, that's the definition of a Bronsted-Lowry acid and base. Ang acid, taga-donate ng proton, while a Bronsted-Lowry base, taga-accept ng proton. Pero meron pa rin kasi mga substances na hindi pa rin sakop ng definition ni Arrhenius at saka ni Bronsted-Lowry. Kaya meron pa tayong pangatlong definition, which is the Lewis acid and base. Okay? So, according to Lewis, an acid is a substance that is an electron pair acceptor. Electron pair naman yan. Okay? While a Lewis base is an electron pair donor. Ang acid, acceptor. Electron pair acceptor. Electron pair donor naman ang Lewis acid. Para may compare lang natin ha, ang Bronsted and Lowry acid, this is a proton donor. Okay? Pero sa Lewis acid, electron pair acceptor siya. For a Bronsted and Lowry base, okay, ito naman ay proton acceptor. Pero sa Lewis base, electron pair donor naman siya. Okay, so paano sila, yung mga Lewis acid and base, paano sila nagpo-form ng hydrogen or hydrogen ion or hydroxide ions? So, example natin dito ay, for a Lewis acid, diba sabi natin, ang Lewis acid ay electron pair acceptor. Now, in this case, ang example natin ay boric acid. Boric acid. So, definitely, ito yung acid natin. Okay? Now, paano siya nagiging electron pair acceptor yung Lewis acid natin? Itong boric acid kasi na to, hindi siya, though may mga hydrogen siya, hindi siya mamimigay ng proton or ng hydrogen. Ang mangyayari kasi dito, though medyo sisimplihan ko na lang ang discussion dito ha. Ang mangyayari, yung water natin, di ba? This is H, O, and H. Mangyayari, ito kasing si water, meron itong yung oxygen natin sa water, meron siyang dalawang lone pairs pa na nakalagay diyan. Okay? Itong mga lone pairs na ito, palitan lang natin yung kulay ng ating Ayan. Ayan. So itong mga electron pairs na ito, okay? Ito ay iko-connecta kay boron. Okay? At dahil tumanggap ng electron pair itong si boron mula kay water, then it is a Lewis acid. Now, ito kasi hindi mananatiling buo itong si water kapag nag-donate siya ng electron pair kay boron. Magdi-dissociate itong part na ito, okay, to form the hydrogen ion. Okay? Itong hydroxide na yan, dadagdag yan sa structure ng boric acid to form this. Hindi ko alam kung anong tawag dito sa structure na ito na medyo complicated na yung structure niya. Okay? So, yan. So, nakapag-form pa rin tayo ng hydrogen ion. Okay? Kahit na wala naman talagang binigay na hydrogen ion o ng proton itong si boric acid. So, saan nanggaling yung proton? Nanggaling yun kay water. Okay? nung nag-donate ng electron pair, itong si water kay boron. Okay? So, si boric acid, siya yung ating Lewis acid. At dahil ang nag-donate naman ng proton ng electron pair ay si water, then this is our Lewis base. Pwede rin siyang tinayin nyo yung mga definitions natin. Yung water pwedeng mag-act as a bronzidine acid or a base. Pwede siyang mag-act as a Lewis base. Okay? So swak siya sa maraming mga definitions natin. Okay. Now next, how about the Lewis base? Electron pair donor naman. So example pa rin natin dito ay ammonia. Okay? So sa ammonia, ang ammonia kasi, ito yung structure niya. We have hydrogen, nitrogen, hydrogen ulit, at hydrogen ulit. Ang nitrogen kasi, 5 ang valence electrons niya. So, meron ng 1, 2, 3, na nakaband sa hydrogen. Tapos meron pa siyang 2 dito. Okay? So, meron siyang electron pair o lone pair. Ngayon, paano naman si water? Si water naman dito, di ba? Siya ay H, O, and H. Okay? In this case, ang mangyayari, pwede kasi itong mag-dissociate eh. Yung banda eh, pupunta yan dito. So, magiging H positive yan. At yan ang makikipag-interact sa lone pair ni nitrogen. Kaya, kung titignan nyo dito sa structure natin, ito na siya. Yung hydrogen isang hydrogen ni water, kumabit dito sa lone pair ni nitrogen. Kaya ito na yun. So, ito na siya. Ayan. Okay? Tapos yung hydroxide ion na natira nung umalis yung isang hydrogen, ito na yun. Okay? So, yung ating electron pair donor, si ammonia. Ito yung electron pair kasi natin eh. So, in this case, since nag-donate ng electron pair, itong si nitrogen o si ammonia kay water, then ammonia is a Lewis base. Samantalang si water, dahil siya ay nag-accept ng electron pair mula kay ammonia, then mag-act naman siya dito as a Lewis acid. Okay? So, to recap, ito yung mga definitions natin ng acid. Arrhenius acid, ionize in water to produce hydrogen ions. Okay? So, katulad ng HCl, pag dinisolve natin sa water, magpaproduce ng hydrogen ion. Bronzidine acid naman, yung ating acid, ang acid ay substance na nagdo-donate ng proton. So, ito yun. Ito yung ating proton na idodonate niya kay water. At ito yung mabubuo natin. Hydronium ion, again, yung hydronium ion na yan, H positive din lang yan na nag-react with water. Yan din yun. Okay? So, ang Lewis acid naman, electron pair acceptor siya. So, kapag nag-accept siya ng electron pair mula kay water, okay, makakapag-produce pa rin siya ng hydrogen ion. So, basta ang acid ang pinag-uusapan natin, dapat tataas o mag-i-increase yung concentration ng hydrogen ion sa ating solution. Okay? Now, how about base? So, arrhenius base, it ionizes in water to produce hydroxide ion. So, ito siya. Yung substance mismo natin na base, meron siyang hydroxide. Pag nag-dissolve in water, it will form hydroxide ion. Okay? Now, dito naman, sa bronzidine base, siya naman yung substance na nag-accept ng proton. So, since itong nag-donate ng proton, okay, itong si acetic acid, nag-donate ng proton, so, mag-act siya as a base in this case. Okay? Dito nga lang, ang naipakita kasi natin na yan ay hydronium ion. Okay? Pero kasi itong ammonia, pwede na natin siyang gamitin as an example for for bronzodendroic base. So, example natin sa Lewis acid, electron pair donor naman ang isang base. So, dahil nga merong lone pair pa itong si ammonia, so tatanggap siya ng proton. Okay? Or idodonate niya yung kanyang electron pair sa proton, yung hydrogen ion, ng water. So, pwede tayo makapag-produce ng OH negative pa rin dito, at ito na yung kalalabasan niya. Tapos yung hydrogen ion na kumabit kay ammonia, ito na siya. Okay? Yung ammonium ion natin. Okay? So, hindi pala ito magandang example yung nilagay ko sa bronzodendroic base. Pero ito kasi, makaklasify pa rin natin siya as a base. Okay? Kasi nga, siya ay tumanggap ng proton mula sa isang acid. Okay? So, meron pa tayong ibang mga types ng acids. We can classify acids as monoprotic. Ibig sabihin, isa lang yung proton na kaya nilang ibigay. Pwede rin diprotic. Ibig sabihin, each unit of the acid gives 2 hydrogen ions in 2 separate steps. So, halimbawa, ito yung sa sulfuric acid. Pwedeng isang hydrogen ion muna yung kaya niya ibigay. Tapos, may pangalawa pang step, makapagbigay pa uli siya ng isa pang hydrogen ion. So, dalawang protons yung kaya niyang i-donate. Pag triprotic naman, as the term implies, 3 protons yung kaya niyang i-donate. So, ito yung mga yun. 1, 2, 3. Phosphoric acid ang example natin. Okay? So, ito, medyo kailangan yung tandaan itong mga to para sa susunod, kapag maka-encounter kayo ng mga acids, basta kabisado nyo na yung 6 strong acids, lahat ng ma-encounter nyo pa ng mga acids sa susunod, ay mga weak acids na yon. So, ito mga to, yung perchloric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, and sulfuric acid. These are strong acids. At kapag sinabi natin strong acids, they completely dissociate to form hydrogen ion. So, halimbawa, we have ito HCl. So, irreversible reaction yan palagi pag strong acids. So, it will form H positive plus Cl negative. So, again, kapag strong acids, okay, irreversible yung reaction. Ibig sabihin, talagang diretso na completely mawawala itong HCl natin para makapag-produce ng hydrogen ion and yung anion natin. Okay? So, sa lahat ng cases na yan, lahat ng mga yan, sila ay mag-undergo ng complete dissociation to form hydrogen ion and the anion. Okay? So, ito yung mahalaga na kailangan nyo tandaan itong 6 na strong acids na ito. Perchloric, HCl, HBr, HI, nitric, at saka sulfuric acid. Okay. Now, balikan lang natin itong bronzodendroic acid and base. Okay? So, again, sa discussion natin kanina, itong ammonia, since siya ay tatanggap ng proton, okay, ng H+, mula kay water, then, ammonia will act as a base, while water will act as an acid. Now, take note that this chemical reaction is a reversible reaction. So, yung ammonia natin na tumanggap ng hydrogen ion, siya ngayon ay magiging ganito. H4 plus. Tapos si water na natanggalan ng hydrogen ion, magiging hydroxide ion naman siya ngayon. Okay? Now, since this is a reversible reaction, magre-react ulit silang dalawa. Yung ammonium ion natin at saka yung hydroxide ion natin. Ibig sabihin, yung extra hydrogen ion na nakakabit dito, magre-react uli siya kay hydroxide ion para maging water uli siya. Ayan, yung hydroxide babalik sa pagiging water at yung ammonia, matatanggalan siya ng H positive, babalik siya sa pagiging base. So, ngayon, ano yung parang nature ng ammonium dito? Since ang ammonium ay mag-donate ng proton kay hydroxide, this will act as an acid. Pero we call this as a conjugate acid. Okay? Pag sinabi natin conjugate acid, this is a Bronsted-Lowry conjugate acid of a Bronsted-Lowry base is the species formed after a base accepts a proton. Yung base, nakatanggap siya ng proton, magiging conjugate acid siya. Okay? While an acid that donates a proton, okay, will become a conjugate base. Okay? Kasi dito sa reaction na ito, dahil siya ay tumanggap ng proton, okay, siya ngayon ay mag-act as a base. Okay? So, yun yung definition natin ng acids and base sa Bronsted and according to Bronsted and Lowry. Okay, we have the base, Bronsted-Lowry base, and Bronsted-Lowry acid, and their conjugates, conjugate acid and conjugate base. Basta tatandaan ninyo, yung nag-act as a base, it will form the conjugate acid. While yung nag-act ng acid, it will form the conjugate base. Okay. So, yan yun. To sum it up. Okay. So, that's Bronsted and Lowry acid and base. Now, let's talk about the acid-base properties of water. Kasi nga, di ba, yung water, it can dissociate to form hydrogen ion and hydroxide ion. So, water can act both as an acid and as a base. Katulad nga ng mga pinakita kong examples kanina. Depende kung anong substance yung kasama ng water, pwede siya mag-act as an acid or as a base. Kung strong acid yung kasama ng water, mag-act yung water as a base. Pero kung strong base naman yung kasama ng water, then water will act as an acid. So, ganun siya. Depende sa kasama niya. Kung ano yung magiging nature niya. So, parang balimbing. Ganun. Okay, so, water is a very weak electrolyte or a poor conductor of electricity. Okay? And it undergoes auto-ionization or self-ionization. And amphiprotic din siya or amphoteric. So, ito nakuha nyo na yung definition nito dati, di ba? Pag amphiprotic, ibig sabihin, pwede siyang tumanggap or magbigay ng proton. Amphi, ibig sabihin, pwede mag-accept or mag-donate ng proton. Amphoteric naman, ibig sabihin, pwede siyang mag-act as an acid or as a base. Okay, so ito yung auto-ionization or self-ionization ng water. So, if you have two molecules of water, okay, pwede siyang mag-dissociate to form hydroxide ion and hydronium ion. Pero yan ay napakadalang, napakabihirang mangyari yan. At, syempre, kapag sila ay nag-dissociate to form hydroxide ion and hydronium ion, babalik din sila sa dati into water molecules. Okay? So, acid or base, pwede sila mag-act as an acid or as a base. Ganun din, ito, yung conjugate acid-base pair nila. Okay? Now, dito, i-relate na natin yung equilibrium. Since ito ay reversible reaction, pwede na natin i-relate dito yung equilibrium expression. Okay? Since yung reactants natin ay parehong liquid, again, kung i-recall natin yung sa chemical equilibrium, hindi natin isinasama sa equilibrium expression natin yung liquids pati solids. Okay? Yung aqueous solution lang at saka gas ang ini-include natin sa equilibrium expression. Kung tatandaan ninyo, di ba, yung K is equal to concentration of product over the concentration of the reactants. Okay? Pero since pareho ng liquid yung ating mga reactants, then wala na ito. So we will only have the concentration of the hydronium ion and the concentration of hydroxide ion. Now, at 25 degrees Celsius, it was found out that the equilibrium constant or the ionization constant of water is this. Okay? So, it's 1.0 times 10 to the negative 14. Okay? Or, yung Kw dito, this is the ion product constant of water. Okay? And this is equivalent to 1.0 times 10 to the negative 14 according to experimental data. Okay? So, therefore, since, kumbaga kung simple lang to, simple algebra, okay, Kw is equal to, since, ito kasi, pareho lang naman sila ng amount na na-produce. So, this is X times X. So, this is X squared. So, if you get the square root of Kw, then we will be able to determine the concentration of hydronium ion and hydroxide ion. If we get the square root of Kw, which is 1.0 times 10 to the negative 14, nakalalabasan natin ay 1.0 times 10 to the negative 7. Okay? So, ito. Ito nga yun, di ba? Kw is equal to 1.0 times 10 to the negative 14. So, again, to solve for this, ayan, so the concentration of H3O positive is equal to, okay, kung gusto nyo ng medyo mahaba-habang solving, okay, 1.0 times 10 to the negative 14 over 1.0 times 10 to the negative 7, tulad ng calculation nga natin. Then, you will get concentration of H3O positive is equal to 1.0 times 10 to the negative 7. Ganon din dito sa hydroxide. Okay? Concentration of hydroxide ion is equal to 1.0 times 10 to the negative 14 over 1.0 times 10 to the negative 7. So, the concentration of hydroxide ion is equal to 1.0 times 10 to the negative 7. Parang hirap i-handle ng gantong number, no? Kasi ang haba masyado. So, ang ginawa nila dyan is they look for the para medyo maging manageable naman yung number na yan. They use logarithm. And that is by getting the negative logarithm of 1.0 times 10 to the negative 7. Okay? At ang symbol natin yan ng negative logarithm in mathematics, that is P of hydronium ion. Pero pwede nga natin kasi isulat yan as H, di ba? H positive. So, P again stands for negative logarithm of hydronium ion. We will get, so, hindi na kasi, hindi ko na maisulat. So, we will get, ang negative logarithm ng, ano to? Ng 1.0 times 10 to the negative 7. This is equal to 7. Kahit nakunin nyo pa sa ano yan, sa calculator ninyo. So, P H How about itong hydroxide ion naman natin? So, para maging manageable din yan, we get POH negative, or this is negative logarithm of 1.0 times 10 to the negative 7. So, the POH is now equal to 7. Okay? So, medyo manageable na kumpara sa 1.0 times 10 to the negative 7. Napakahaba. Okay. So, ayun na. Na-review na natin yung next topic, next concept, which is pH. pH is a measure of acidity. Naalala ko yung kwento tuloy ng prof namin. Nagkaroon talaga ng conference kung between several countries kung ano ba ang pwedeng gamitin ng mga scientists na symbol for the strength of an acid. So, sa math kasi nga, P stands for for negative logarithm. So, how do we define pH? How do we describe pH ngayon? So, sa iba't ibang bansa daw kasi iba-iba yung definition, kumbaga, may mga terms sila na ginamit na nagkataon na pare-pareho nag-start sa letter P. Halimbawa, so, since ang pH is actually nagre-refer sa concentration ng hydrogen ion sa liquid. Sa Amerika daw, they use power of hydrogen ion. So, tama. pH, power of hydrogen ion. Sa France daw, potence naman ang ginamit nila na term, potence ng H. So, pH pa rin. Tapos, sa ang pambansa yun. Ayun. So, nagkataon na pare-pareho lang pala yung mga terms na na ginagamit ng mga iba't ibang mga scientists. Okay? They all start with P. Okay? Kaya, nagkasundo sila na ang gamitin lang nila na symbol for the strength of an acidity is pH. So, yung acceptable definition ngayon ng pH ay power of hydrogen ion. Pero ito yung medyo technical na definition. Negative logarithm of the hydronium ion concentration. Okay? So, negative logarithm of the concentration of hydrogen ion. Or, yung mas maiksi nga na definition natin dyan, this is power of the hydrogen ion. pH. Okay? So, again, ito nga yung ating mathematical expression yan. pH is the negative logarithm of the concentration of hydronium ion, or pH is the negative logarithm of the concentration, again yung bracket, diba? Concentration of hydrogen ion. Okay. So, ito naman yung, para makuha naman yung concentration ng hydronium ion, o hydrogen ion, yung pH natin, gagawin natin siyang exponent, pero negative exponent. Okay? So, POH. POH is the negative logarithm of the hydroxide ion concentration in mole per liter or in molarity. So, ganun din yung concept niya. Okay, so pH and POH, pag pinagsama natin sila, okay, that should be equivalent to so, negative logarithm ng concentration ng hydrogen ion, okay, pati ng hydronium ion, this should be equal to the negative logarithm of the Kw natin, which is 1.0 times 10 to the negative 14. So, therefore, okay, pag kinuha natin ito negative logarithm ng 1.0 times 10 to the negative 14, 14 yung magiging katumbas niyan. Ganon din ito. Ito naman ay magiging 7, tapos ito naman ay magiging 7. So therefore, if pinagsama natin yung pH and POH, this should be equivalent to 14, which is the negative logarithm of the Kw natin. Okay? So yan. Now, ito, kailangan nyo tandaan, a neutral solution has a pH of -7. Samantalang ang pOH niya ay 7 din. Kapag acidic naman ang solution, then yung kanyang concentration, yung kanyang pH ay less than 7, while pOH niya ay greater than 7. Now, magbigay ako ng example dito. Bakit acidic kapag yung pH mo ay less than 7? So again, yung neutral kasi natin, di ba? This is 10 raised to the 1.0 times 10 to the -7. Kapag ito yung concentration ng natin, ng hydrogen ion, then masasabi natin na neutral lang siya. Okay? Now, what if tinaasan natin yung concentration ng hydrogen ion natin? At kapag tinaasan, ibig sabihin, bababaan natin itong exponent na yan. Halimbawa, 1.0 times 10 to the -5. Okay? So, mas mataas na yung concentration natin ngayon kasi yung exponent natin naging -5 na eh. Mas maliit mas liliit ang mas liliit ang value ng number natin kapag yung exponent natin ay mas malaki yung number ng negative exponent natin. So, ito ay smaller value, smaller. Ito ay larger value to, ha? Baka nalilito lang, baka malito kasi yung iba. Kapag ito yung concentration natin ng hydrogen ion natin. So, let's look for the pH. So, pH is equal to the negative logarithm of 1.0 times 10 to the -5. Ano ang kalalabasan niyan? Ito yung calculator ko. Tingnan nyo rin sa calculator ninyo. So, negative logarithm ng 1.0 times 10 to the -5, that is equivalent to 5. So, your pH now is 5. Nung tinasan natin yung concentration ng hydrogen ion, okay? So, ibig sabihin, mas nagdagdag ka ng mas maraming acid. So, magiging acidic dapat yung solution natin. Ano ang nangyari sa pH? Ang nangyari sa pH ay bumaba. Okay? So, if you have a pH that is less than 7, okay, ibig sabihin, tumataas yung concentration ng hydronium ion natin. Okay? At kabaliktaran naman yung mangyayari sa pOH natin, tataas yung pOH. But for a basic solution, yung pH natin ay mataas, greater than 7, yung pOH naman ay less than 7. Okay? Here are some substances na mga common substances and their pH. Yung sodium hydroxide na may concentration na 1 molar, okay? 14 yung kanyang pH. Actually, itong lye, sodium hydroxide din yan eh. Pero siguro yung commercially available na lye, nasa 13 yung pH kasi dissolved in water na yan eh. Tapos mas mababa ng konti yung amount niya. Okay, household ammonia, yung ginagamit natin, let's say may mga hinihimatay, yung mga pinapasinghot sa mga hinihimatay, pH 12 siya. Milk of magnesia, alam ko, pag may upset stomach or hyperacidity, yun yung pinapa-inom minsan. Okay, and detergent, mga approximately 10 yung kanyang pH. Seawater, it's in between 7 to 9 kanyang pH. Or, ayan, 7 to 8.3. Ang blood naman natin ay malapit-lapit sa neutral pero slightly basic siya, 7.4. Ang neutral ay 7, which is yung pure water. Ang milk ay slightly acidic. Okay? So, by the way, tingnan ninyo ha, yung blood ay 7.4. Ibig sabihin, slightly basic siya. Kapag maging masyadong acidic yung katawan natin, hindi na magpa-function na maayos yung dugo natin. Kaya, samot-saring sakit ang mararanasan natin kapag masyado nang maging acidic ang katawan natin. Okay? So, normally or naturally, yung dugo natin ay nagka-function at a slightly basic condition. Kapag masyado na maging acidic ang dugo natin, magiging masama na yun. Hindi na siya makakapag-function ng maayos. And so on. Ayan pa yung mga acidic naman natin, mga substances. Yung unpolluted rain, medyo acidic. Beer ay acidic. Of course, ayan yung mga yan. Siyempre, acidic na yung mga yan. Okay. Now, calculating the pH of a strong acid muna tayo. Okay, so what is the pH of a 2.0 times 10 to the negative 3 molar nitric acid solution? Okay, so ito yung equation natin. So kapag strong acid ang pinag-uusapan natin, again, sana nakabisado na ninyo yung mga strong acids natin na. And one of those strong acids is nitric acid, HNO3. Kapag strong acid, again, irreversible yung reaction. One way lang siya. Ibig sabihin, lahat ng nitric acid natin ay mako-convert into hydrogen ion and nitrate ion. So, madali lang yung pag-calculate ng pH ng strong acid. So, i-list lang natin kung ano yung concentration niya at the start, which is 2.0 times 10 to the negative 3 or 0.003 molar. Tapos, wala pa tayo nito. At the end of the reaction, ano mangyayari? Mauubos na to. At pareho na tayo magkakaroon dito ng 0.003 molar ng H positive at 0.003 molar ng NO3. Now, again, pag pH ang pinag-uusapan, ito lang ang concern natin, yung concentration ng hydrogen ion, which is 0.003. Ito, ignore na natin yan. So, pH now is, again, the negative logarithm of the concentration of hydrogen ion, which is 0.003. So, ang pH natin ngayon, calculate natin, negative logarithm of 0.003 ay, ang pH natin ay 2.52 or 2.5 ang ating pH. Ganun lang kasimple ang pag-compute ng pH ng isang strong acid. Okay, next. How about calculating the pH of a strong base? Ganun din lang. Medyo madali lang siya, pero may additional step lang tayo na gagawin. So, example natin is, what is the pH of a 1.8 times 10 to the negative 2 molar barium hydroxide? So, barium hydroxide is also a strong base. So, it will, basta, masasabi niya na strong base siya kapag irreversible din yung reaction. One single arrow lang siya. Okay? So, ibig sabihin, at the start of the reaction, we have 1.8 times 10 to the negative 2 or 0.02 molar na barium hydroxide. Wala pa tayong barium positive at OH negative. Okay? And then, at the end of the reaction, wala na to. Kasi lahat ngayon, yung barium hydroxide natin, makakonvert into barium positive, 2 positive yan, and 2 moles of hydroxide ion. So, we will have 0.02 molar nito. At ito naman ay 0.02 times 2. Kasi dalawang moles yan eh. So, 0.04 molar. Again, bakit siya naging 0.04? Kasi nga, dalawa yung moles ng hydroxide ion natin. Okay. Now, in this case, OH kasi siya. So, this is POH. POH is equal to the negative logarithm of 0.04. Okay? So, POH now is equal to, ano ang POH? natin dyan. So, negative logarithm of 0.04 is 1.4. Okay? Pero, ang tinatanong sa atin ay pH. POH yung na-compute natin. Now, again, going back, di ba? pH plus POH is equal to 14.0. So, to get the pH, we just, okay, subtract the POH to 14.0. So, 14.0 minus the POH to get the pH. So, pH now is 14.0 minus 1.4. So, 14 minus 1.4 is 12. So, ang pH natin ngayon, hindi na kasya, hindi ko na maisulat. pH now is 12.6. So, this is our pH. So, ito lang yung extra step na gagawin natin kapag ang base ang given sa atin. Okay? So, tandaan nyo lang itong very simple na equation. So, pH plus POH is equal to 14.0. Okay. Now, ibang usapan na kapag weak acid ang kukunan natin ang pH. Bakit? Kasi sa weak acid, okay, this involves a reversible reaction. At kapag reversible na ang reaction, then i-consider na natin dito yung kanyang equilibrium constant. Ayan na, yung diniscuss natin nung nakaraan. Chemical equilibrium, napasok na siya. So, in this example, we are going to calculate for the pH of a weak acid. So, what is the pH of a 0.15 molar acetic acid? This is acetic acid. Acetic acid solution. And the Ka or dissociation, ion dissociation constant niya ay 1.8 times 10 to the negative 5. Okay, so how do we compute for the pH of acetic acid in this case? Weak acid siya. So, eto, sulat natin siya. So, we have ito yung equation, chemical equation natin. We have as acetic acid will yield hydrogen ion and acetate ion. But this is again, a reversible reaction. So, tulad ng ginawa natin dati sa chemical equilibrium, gagamit tayo ng ice table to compute for the concentration of our hydrogen ion in this chemical equation at equilibrium. So, initial. Ano ba yan? Ayaw. Ayan. Ayaw niya. Anyway. Ayan. So, initial. Ito nga, kaya siya ice table kasi. Ayan. Start tayo sa I. So, initially, we have 0.15 molar nito. At wala pa nito. Okay? Now, C naman tayo. Ang C ay change. Ano mangyayari? Siyempre, some of the reactants will be converted into the products. Pero hindi siya completely magta-transform into the products kasi nga reversible reaction yan eh. So, mababawasan lang siya. Pero kung gaano karami yung mababawas, hindi natin alam. Kaya, i-represent natin siya as minus x. Kasi matatagdag dito, hindi rin natin alam. Kasi hindi nga natin alam kung ilan yung mababawas sa reactant natin eh. So, plus x na lang siya. Plus x. And plus x. So, ano na ngayon yung mangyayari at equilibrium. So at equilibrium, we will have 0.15 minus x. Tapos, yung products naman natin, we will have x and another x. If we are going to write the equilibrium expression for this, okay, ito yung products natin, ito naman yung reactant natin. So, ang Ka natin ay 1.8 times 10 to the negative 5. So, di ba ang formula natin for chemical equilibrium is K is equal to the concentration of product over the concentration of the reactant. Pero since alam na natin na 1.8 yung Ka natin, so this is 1.8 times 10 to the negative 5 is equal to, okay, so ang product natin, dalawang x, so x times x, so this is x squared, over, yung reactant natin, this is 0.15 minus x. Okay, mamaya may tuturo akong shortcut dito sa inyo. Pero, for the meantime, gawin muna natin yung long method ng pagsosolve dito. Okay? So, let's solve for x. Transpose natin ito dun sa kabila. So, cross-multiply natin. So, we will get, ano to? So, 1.8 times 10 to the negative 5 times 0.15 minus x. So, we will get 2.7 times 10 to the negative 6 minus 1.8 napilit 1.8 times 10 to the negative 5 x is equal to x squared. Okay, so napapansin ninyo, may x squared, may x, tapos walang symbol. So, anong papasok sa isipan nyo kapag ganyan yung structure ng natin, ng equation natin? This is a quadratic equation. So, i-rearrange natin siya, transpose natin itong dalawang to, okay, sa kabilang side. So, we will get 0 is equal to x squared, okay, i-rearrange natin siya na maayos, plus 1.8 times 10 to the negative 5x minus 2.7 times 10 to the negative 6. So, sa case na to, para ma-solve natin yung value ng x, we will be using the quadratic equation. And again, the formula for the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So, this is our a, b, and c. Ang a natin dito, 1 lang. 1 lang yan. Okay? As dito naman yung b natin, syempre hindi nakasama, hindi nakasama yung x, ito lang siya. 0.8 times 10 to the negative 5, plus ang c natin, ito na siya. Negative, kasama yung symbol, negative 2.7 times 10 to the negative 6. So, buburahin na muna natin ito kasi hindi na magkakasya. Mahirapan na tayo mag-solve. Medyo haba na kasi itong na to. So, please take note na lang yan. Wait lang. Linis. Erase. I-retain lang natin itong nasa baba para meron tayong mapagkokopyahan. Ayan. So, sulat na ulit tayo. We have x is equal to, ang b natin ay magiging negative 1.8 times 10 to the negative 5 plus or minus the square root of, okay, ang b squared natin, of course, that's 1.8 times 10 to the negative 5 squared minus 4 times 1 times, ang c natin ay negative 2.7 times 10 to the negative 6 all over, so yung a kasi natin 1 lang, so all over 2. Okay? So, you will get negative 1.8 times 10 to the negative 5 plus or minus the square root of, so anong 1.8 times 10 to the negative 5 squared? That is equivalent to 3.24 times 10 to the negative 10. Okay. Ano naman itong 4 times 1 times 2.7 times 10 to the negative 6. That is negative, kasi ito, negative to eh. So, pag pinag-multiply natin silang lahat, magiging negative 1.8 times 10 to the negative 5. Eh, minus to. So, gagawin natin siyang positive ngayon. Plus 1.08 times 10 to the negative 5. Okay? All over 2. Pwede natin itong burahin nasa baba. Ay, sulat na natin naman na. Dito, burahin na natin. Ayan. Okay. So, ano na ang kalalabasan yan? Since ito ay negative 10, no? Napakaliit na number niyan kumpara sa negative 5. So, kalalabasan talaga niyan ay ito lang talaga mareretain. So, 1.8 times 10 to the negative 5 plus or minus the square root of 1.08 times 10 to the negative 5 all over 2. Okay? So, this is, anong square root ng 1.08? So, this is, kalalabasan niyan is negative 1.8 times 10 to the negative 5 plus or minus 3.27 times 10 to the negative 3 all over 2. Dito, pwede na natin ngayon isa-isahin yung pagsasolve niyan. So, dalawa ang pwedeng kalabasan niyan. You will get ito. Pwedeng x is equal to 1.63 times 10 to the negative 3 yung value ng x natin. Or, kapag kapag minus yung sinode natin, then x is equal to 4.49. So, alin dito yung mas tama? Ito bang nasa taas? Yung plus o yung minus? Alin yung mas appropriate dyan? O, tingnan natin. Yung, di ba yung sa equilibrium, kanina, yung reactant, ito, sulat na natin. Buray natin itong nasa taas. Total, nasolve naman na natin. Ayan. So, we're going to recall at equilibrium, di ba? We will have 0.15 minus x. Ito ay plus x. Plus x. Tapos plus x din ito. Kung ito ang gagamitin natin, ano mangyayari? Sobra-sobra siya. Hindi naman pwedeng ganun, di ba? Mag-minus ka sa 0.15 ng 4.49. So, sobra-sobra to. So, mali ito. Okay? Ang pwedeng, magamit natin dito ay ito. Ito yung tama. 1.63 times 10 to the negative 3 lang. Yung maibabawas natin sa original concentration ng acetic acid. Okay? So, therefore, ang value ng X, kasi ito lang naman talaga yung habol natin. Yung concentration ng hydrogen ion. So, therefore, X is equal to 1.63 times 63 times 10 to the negative 3. Kasi, para nga makompute natin yung pH, kailangan malaman natin yung concentration ng H. So, to solve, pH is equal to the negative logarithm of the value of X. Wait, hindi pa pala. Kasi meron tayong value ng tama, okay na pala yun. Nagamit na pala natin yung Ka. So, ayan. 1.63 times 10 to the negative 3. So, pH now is equal to, ano kalalabas sa pH niyan? Negative logarithm of 1.63 times 10 to the negative 3. So, our pH now is 2.78. So, yun. Medyo complicated lang talaga siya kasi gagamit tayo ng ice table and gagamit na rin tayo ng quadratic equation. Okay, to solve for the pH of a weak acid. Okay? Now, actually merong technique din dito yung tinatawag nila na approximation at saka yung 5% rule. Ganito lang siya. Okay? Para di ba yung sa Ka natin kanina? Yung equilibrium constant expression natin. Ka is equal to x squared over 0.15 minus x. Pwede ma-simplify yung calculations natin dyan. Itong Ka nga pala is 1.8 times 10 to the negative 5, di ba? Okay. Yung Ka kasi natin ay napakaliit. 1.8 times 10 to the negative 5. So kapag ganyan, tas yung original concentration pa natin ay medyo malaki, 0.15. Kapag ganyan, pwede tayong mag-approximate. So kapag ang concentration natin is around 0.1 something, okay? Tapos ang Ka natin is around 10 raised to negative 5. Ito sure na kasi ito eh. Basta ang concentration natin is nasa 1 decimal place. Tapos ang Ka natin ay nasa 10 raised to negative 5. Then itong negative x na to, pwede na nating ignore yan. Napakaliit na ng value niyan. Okay, o try natin, ha? So, if we do this, i-cross multiply lang natin itong 0.15 sa 1.8 times 10 to the negative 5. So, therefore, we will get x squared is equal to 1.8 times 10 to the negative 5 times 0.15. Anong kalalabas na yan? 1.8 times 10 to the negative 5 times 0.15. So, x squared is equal to 2.7 times 10 to the negative 6. You get the square root of both sides of the equation. So, x is equal to anong square root ng 2.7 times 10 to the negative 6. So, that is 1.664 times 10 to the negative 3. At kung mapapansin ninyo, halos pareho lang nito. Diba? So, yun yung so malapit na lang talaga yung yung sagot natin. Yung isa yung long method na gumamit tayo ng tawag dyan ng quadratic equation. Yung isa yung approximation. So, ang tatandaan nyo lang sa approximation, kapag yung concentration natin is around 0.1 or 1 decimal place, tapos yung Ka natin is around 10 to negative 5 or greater pa dyan, greater than 10.0, 10 raised to negative 5. So, hanggang, kunwari, 10 to negative 6, 10 to negative 7, then pwede natin i-ignore or i-cancel out itong minus x na yan. Para pwede na tayo makapagdiretso sa pag-solve ng value ng x. Okay, cancel natin yan. Mas mabilis. Okay? Halos kalapit na talaga ng tunay na sagot. Okay, so that's it for this lesson. Medyo mahaba-haba na. Umabot na ng mahigit 1 oras. And pasensya na, medyo busy talaga ako ngayon dahil sa dami ng pinapagawa. Yung pinapasulat ako ng activity sheet ng DepEd NCR, kaya medyo hindi ko talaga kayo maharap masyado ngayon. So, ayan, medyo busy kayo ngayon dahil sa lesson na ito. So, I'll be leaving you with some activities na sasagutan at ilalagay ko rin yan susunod sa class craft. Pero sagutan nyo muna sa papel, medyo antabi lang muna kayo kung kailan ko mapupost sa Classcraft yung ating homework task. Okay? So, thank you very much sa pakikinig, and that ends our lesson for today. Bye, class!